Many times, our clothes get soiled due to a variety of reasons. Right from dirt while playing to the oil stains while eating, there are many things that can make our clothes dirty. But we don't really have to worry a lot, because the oil, grease, or even the dirt can be easily removed from our clothes. The soaps help us do that. Even the greasy oil on our plates can be removed with soaps. But have you ever wondered how soaps are able to perform this super efficient cleaning activity? What makes soaps so good at cleaning? Couldn't we use only water instead? Not really. Only using water wouldn't be sufficient in most cases, because water is not capable of dissolving oil in itself. That is the reason why oily stuff sticking to our clothes or vessels cannot be removed by water alone. Soaps are the ones that help us in removal of the stubborn particles that stick to our clothes or vessels. But how is this activity carried out? Let's understand this. Here's the typical structure of a soap molecule. The ball on top represents the carboxyl terminal with sodium or potassium attached. This end is called the hydrophilic end or the polar end. In contrast, this terminal is called as the hydrophobic end or the nonpolar end. We just need to understand one thing now. What will happen if the soap made up of many such molecules is added in water? The hydrophilic group loves being in water, but the hydrophobic group wants to get away from water. Thus, the soap molecules start aligning themselves in a particular manner. They will arrange themselves such that the hydrophobic tails come near each other and form a core while the hydrophilic heads face outwards. Now both the groups are benefited with the structure. As the polar groups love water, they form the exterior surface. And since the non-polar groups are scared of water, they come together and form the core that keeps them away from it. This type of arrangement has got a specific name. It's called as a micelle. Now technically, this micelle does not dissolve completely in water. They remain suspended as colloids. So how does it work then? We know that the non-polar group gets attracted towards the organic compounds like oil or dirt. Hence, the micelle comes close to the oil on the vessel or the dirt on the clothes. Let's look at one example now. Assume this is some dirt on a cloth. What will happen next? The strong attraction between the dirt and the micelle will help the micelle to form a circular structure around the dirt. This is how it would look. The polar head will point towards the water and the non-polar tail will point towards the oily dirt. Due to this, the dirt will completely be surrounded by the micelle. The agitation activity of washing helps in these micelles leaving the surface of our cloth. Now what happens because of this? Along with the micelle, the dirt will also leave the surface of a cloth as it gets trapped inside it. As a result, the cloth now becomes free of dirt. This is how soap molecules help us remove the unwanted particles that stick to our clothes.